Hi everybody, I hope you enjoyed that first video. As far as I have ever been aware, that really is a true story about Gauss. That's one of the most famous stories that's told about him. And if you go on and study math further, Gauss is a name you're going to hear quite often. So what I wanted to do is I wanted to take what that video showed you and I want to show you how you can apply it to your homework. So right here on the screen, you can see an example of what your homework's going to look like. I'm going to ask you just a couple of questions that all relate to this. We're going to go through series pretty quickly, but I can tell you that if you're going to go further in math, this is a topic that's going to come up. In fact, this is going to be one of the most important topics in a Calculus 2 class. You're going to be doing something called an integral and use series to describe that. All right, so what we have here is we have two different situations, and I'm going to do one video for each. On the first situation, we're adding together a string of numbers. Anytime you see a ... like they have right there, that just means that they're not going to write out the whole string. I think you can see why we wouldn't want to do that. So from the video, I know that something special is going to happen if I add together my first term and my last term. That the video explained to me that when you add together your first term and your last term, it tells you the height of your rectangle. Now, of course, we have a negative number here, so your rectangle will look a little different. It's going to be hard for me to make a visual out of that. But you still have that same idea of it gives you that height of the rectangle. And we know that the width will equal half of the total number of numbers. And if we can take that 208, that height, times your width, we're going to know how much the sum will be. Now this is going to take just a little bit of work, but it's not something that's too difficult. And I'm thinking I'll probably do a few examples, a few videos, for you to watch as many as you need to. So here I've got my number line. On my number line, I started at -8, and I went to 216. Now, tell me, how is it that I went from this -8 to the next term? What's the pattern there? And what about when I go from the -6 to the -4? Hopefully you can see that each time we're adding 2. So what happens here is I'm going to add 2. I'm going to add 2. If I can figure out how many more times I need to add 2, I'm going to know how this is divided up, and I'll have an idea of how many numbers are in my sequence. So to do that, we need to find the distance between these numbers. And especially if you have been in one of the physics classes, but even if you haven't, the way to find distance is always going to look at the final minus the initial. It really does matter which order you go in. So if I take final minus initial here, I've got 216 minus a -8. And it is important to remember that that is a -8 you're playing with, not a +8. When I subtract, very conveniently, I'm going to end up getting minus a negative is the same thing as plus a positive. And I get out of this, let's see, 224. So this tells me my distance. And I want to know now how I'm dividing it up into sections. So if I take my 224 and I divide it by the width of each section, I'll know how many sections I have. So thankfully this is a pretty easy problem for us to solve. I'm going to run out of room, but you know that's going to cancel. We get that. So there are 212 of these sections dividing my numbers. Does that mean there are 212 numbers total? No, there are not. If I think about a smaller problem, let's say that I'm just going from 0 to 4, and I'm listing out the numbers. Let's say I'm going to go by ones here. So 1, 2, 3. I can see that there are 4 sections when I go between 0 and 4, but if I'm going to list out the numbers themselves, I do include that first number in my sequence, which means there are 5 numbers total. It means there's just one more than what we got right here. So I know that the total number of numbers is 113. And if you don't believe me, let's do the problem in Excel. This is a great way to deal with large groups of numbers. I started at -8, and then in my next term, I took that -8 and I added 2. And this is going to do the math for me. And if you've worked with me with Excel before, and I think you all have, then if I take this and just scroll down, it'll automatically do those summations for me. And I can see that I'm going to get the same sequence that I had here. -8, -6, -4, etc. I want to go all the way to 216. So I drag this down. See where we're at now? 198. That's getting close. I want 216. Now I predicted, based on what I said, that I'm going to get 113 as the total number of numbers. So let's bring this to 113, and I see I get 216 out of this. I'm not opposed at all, by the way, to you using Excel with your work. I will caution you that when you go on to a college class, they won't necessarily accept you using Excel for your homework, but I think it's a fantastic way to check your work. And I hope that even in college you would check your work against this and practice with all the methods that I'm going to teach you and that your college classes will teach you as well. All right, so it wants us to find the sum of these, the sequence. And so remember that my sum is equal to the area of the rectangle. And the area of the rectangle is just width times height. The width was 1/2 of the total number of numbers. And my height was, where was it? It was 208. So one of the other things I really like about Excel is it's a really great just little calculator here. So I'm going to calculate that out here. Remember, when you're using Excel for calculations, you have to put the equal sign in first. And I'm going to put in, I'm going to try to get this so you can see both on the screen. We're going to have equals 1/2 times 113 times 208. And this is the sum that we get. And if I want to check that, I can always come over here to where I have my full sequence and put equals sum, and then I highlight all my numbers, and it will tell me what that equals. And there we go. We get the same sum both ways. Now, I think for practicality's sake, I do think that with what you guys have practiced with math, this Excel sum probably is the one that's going to make more sense. And I know that when you head on to your college classes, this area model version is the one that's going to make more sense, or is going to be the one that they're going to insist on you using. Alright, so I'll do another couple of these, but I'm going to do one video for each example so that you can choose how much you want to watch. And if you need more examples, I want to have those examples for you. So I'm going to explain what this notation is in the next video with this funny looking sideways at.